Welcome to Triangle Concurrency Points. This is a real lesson in vocabulary. What are concurrent lines? Three or more lines intersecting at the same point are concurrent. Then, the point at which they intersect is the point of concurrency. That is what it looks like. There are different types of lines. The perpendicular bisector of a line segment is the line that is perpendicular to the segment at its midpoint. Please notice that on each side of your perpendicular bisector, you have the same amount of line segment. Then we have the angle bisector. The angle bisector is a ray that divides an angle into two congruent adjacent angles that are the same. Okay. Altitude. An altitude of a triangle is a segment drawn from the vertex perpendicular to the opposite side, or to the line containing the opposite side. Okay, a triangle has three altitudes, one for each vertex. A medium of a triangle is a segment drawn from the vertex to the midpoint of the opposite side. Notice that it too cuts the line in half. Also notice that it is not perpendicular. Points of concurrency. There are 4 points of concurrency for triangles, what we call circumcenter, incenter, centroid, and orthocenter. Each is made using different types of lines and has its own properties. Concurrent point circumcenter. This is created when using the perpendicular bisectors of each side of a triangle. Okay, notice that it's just drawn perpendicular to the triangle side and it cuts that line in half. When all three perpendicular bisectors are drawn, the point of concurrency is created is called the circumcenter. The circumcenter is equal distance from each vertex of the triangle. So notice how the ones in red are all the same. When you draw a circle around it, you call this the circumcircle. But notice how those red lines are now the radiuses of that circle. Concurrent point incenter. This is created when using the angle bisectors of each vertex of a triangle. Notice that you draw your line, you're just cutting the angles in half. When all three angle bisectors are drawn, the points of concurrency created is called the incenter. The incenter is equal distance from the sides of the triangle. So if you draw from the incenter down to each side of the triangle, notice how they are all equal distance. Also notice that you can draw a circle and those lines then become the radiuses of that circle. And that circle is called an incircle. Concurrent point centroid. This is created when using medians of a triangle. Remember, the median is drawn from the vertex to the center of the line opposite of it, cutting that line in half. So when all three medians are drawn, the point of concurrency created is called the centroid. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So notice that AB is 2/3 of AC, but BC is 1/3 of AC. We'll go into more detail in this in a few moments. Our last concurrency point is the orthocenter, and this is created when all three altitudes are drawn. The point of concurrency created we call the orthocenter. Orthocenter properties, there are none. The centroid of a triangle is also known as the center of balance. The centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. Again, AB is 2/3 of AC and BC equals 1/3 of AC. So we're going to do some practice here, okay? C is the centroid for this triangle. Notice how RC is 2/3 of your total distance, and then CS is 1/3. So if you're given the total distance RS, what is going to be your value for RC? That's right, RC will be 6. What is going to be your distance for CS? CS would be 3, because 3 is 1/3 of 9. 6 is 2/3 of 9. If they give us the RC value of 8, then what will be the value of the CS? It will be 4. Notice how this is in half of the 2/3 distance, okay? Then what is our total distance for RS? That's right, the total distance will be 12. Here's our last example. We have the value for CS. What is going to be the value of our RC? That's right, it's 14. Notice how that doubles, which means that the total distance for our RS line is going to be, that's right, it's going to be 21. All right, we're going to do some fast answers here. I'm going to ask a question and you need to give the answers. The altitudes are concurrent at the which point of concurrency? That's right, it's the orthocenter. The medians are concurrent at the, that's right, the centroid. The perpendicular bisectors are concurrent at the circumcenter. The angle bisectors are concurrent at the incenter. So this lesson here is introducing you to these vocabulary words, and these you must know. Which point is equal distance from the sides of the triangle? The incenter, and it is created by your angle bisectors. Which point is the center of balance? Centroid, which is created by the medians. Which point is equal distance from the vertices? Your circumcenter, which is created by perpendicular bisectors. Which point is needed to draw a circumcircle? Circumcenter, created by angle bisectors. What point is needed to draw an incircle? Incenter, created by angle bisectors. What point is needed to find the center of balance? Centroid, created by the medians. You're going to fill out points of concurrency graphic organizer. This is a great way to put everything in order so then you can answer questions on it. Thank you very much, and good luck.